Everyone, I hope you're having an amazing day. Welcome to another episode of 10 p.m. University. So today what we're going to do, we're going to talk about the geometric progression. So last time we talked about arithmetic progression. So if you haven't watched that, I would highly encourage you to go and check that out. So what is geometric progression, right? So think about this way. So progression, right? When we talk about a progression is another way of expressing a sequence, right? So geometric progression is also known as geometric sequence, right? So the geometric sequence, often we talk it's abbreviated as GP. So for the sake of simplicity, we're gonna use geometric progression as GP, right? Cool. All right. So GP has a special property that the ratio of two consecutive terms is always constant. This constant ratio is known as common ratio, which is often denoted by R, right? So thus every succeeding terms, right, can be obtained by multiplying the preceding term by a common ratio. So what I meant by that, let's take an example, right? So let's say A is the first term, right? If you remember the first term from the previous AP when we did, right? And the common ratio is R, as we mentioned here. So thus the terms of geometric progression will be something like this. We have AR, A, it's all with A, then we have AR, then AR squared, AR3, up to so on. We're gonna have ARN, right? So the way you calculate the common ratio, right, that's R, that's equals to we gonna divide AR by A, right? So that means, in other words, we can also say any term over preceding term, right? So that's how you calculate the common ratio. So we have a equation, or you can say a tool or a formula, which will help you. So that is Tn. So that's a general term of a GP, right? It can be expressed in the form of Tn equals to AR to the power n minus 1, right? This sounds nice and easy, right? So it will become more clear when we do a different exercise, right? So I will do some hands-on with different examples, right? So that will make it more clear for you, the concept. I understand that it can be a bit overwhelming, similar to AP. So AP, what we're gonna do when you find a D, that so you normally subtract these two, so that's A and AR, so you get the D. So in this case, we're dividing it. So so what we're gonna do, let's take first example, right? The example number 1. Find the 7th term of GP of we have a sequence, right? Okay, and now we're gonna find this. We need to find the 7th term of GP. Right, now how do you find it? So first thing, we need to look for A, right? So A is the first term, right? A equals to 1, right? And now R. So if you remember from this equation, AR by A, so what we're gonna do, we're gonna calculate what is AR. This is 1 by 2, right? And divided by 1. So this will become 1 by 2, right? Sounds easy. Now, use this equation, Tn equals to AR to the power n minus 1, right? So what are we gonna do? Tn, what is n? We're gonna find the 7th term of GP. So we're gonna put T7 equals to, right? And then what is A in this case? It's 1 times, right? And then we're gonna find what is R, right? So R is 1 by 2, right? And what is n minus 1? That's equals to 7 minus 1, right? So that's what equals to 1 by 2 times 6. 4, 8, 16, so 2 times 2, 4, times 2, 8, times 2, 16, right? Times 2, 32, times 2, 64. So this equals to 1 by 64, right? So this is how you find out. So we're gonna do more, right? So let me clear the screen. So I hope it's a bit clearer for you guys. So it's pretty straightforward. You need to find the first term, then you need to find an R, and then you need to use this specific formula or equation, right? So that will give you, if you wanted to look for a specific term of a GP, right? So this is how you calculate it, right? Sounds easy, right? Cool. Okay, let me clear this. Right. So as I mentioned in my previous episode, that I'm gonna do one more maths, and then we're gonna move on to another topic. I will find out what is that we need to do. Probably, you know what, I was thinking to do art, but then I realized, right, it takes some time to investigate, about art. So for that, and I'm gonna do something else. So probably, my apologies. I'm gonna start a programming series for a week. We're gonna talk about different programming language. I'll try to cover the basics of 7 programming language in a week, so that if you want to be someone who wants to look to be a programmer, wants to become a programmer, we'll give you a starting point, right? So everything in a one video, right? If I think that if there's a requirement to make another video of the same programming, we're going to do that, because I'm not going to get into the details in extensive details, but just want to give you a heads up so that you can go and start researching and start playing around with it. So that's the whole plan. So yeah, as I mentioned about the arts, and I need to investigate a little bit more. I need to talk about the people that's associated with the art world. Probably going to go back to 16th century. You need to dig up some stuff, right? So yeah, it's going to take some time, the research and investigation, or if you call it that way, right? Because all these things needs a lot of research behind the scene, right? So to prepare content, and I hope you appreciate how much time that's gone into this kind of creating the content, right? First I did the health week, then I'm doing the maths week, then so all right, sorry I digress. Just wanted to give you a heads up. So okay, all right, cool. So we're gonna do one more exercise here. So we're gonna do find so this is the second exercise. Find the 6th term of a GP, right? For 36 minus 12, 4, right? So now A, as usual, is 36, right? Now R, so that is minus 12 by 36, right? Now if you know the multiplication table of 12, so it will become 1 by 3 minus, right? 12 times 3 equals to 36, right? So R equals to 1 by 3, and now we got A. So now it's pretty straightforward, right? Now we have this equation. So T of 6 now equals to 36 times, right? Now we have minus 1 by 3, 6 minus 1, so that's equals to 36 times, minus 1 by 3, that's equals to 5. So that's equals to 36 times 1 by 3 times 9, 27. So it's approximately 3. Let me calculate. So 243, I presume, equals to. So this is pretty straightforward. So if you use so it will become goes here, it will become minus 4, 27. Okay. Right. Okay. So right. Okay. I hope that's correct. Right. So I mean, you can work out using calculator, right? So so this is how you calculate the 6th term of a GP, right? So starting with A, then you work out R, and then you use this equation or formula to calculate the value of the terms, right? So that's pretty straightforward, right? Okay, now we're gonna do in a very different exercise now. So let's say we have A, B, C, D. They are GP, right? So let's say we have a sequence and we call the sequence as a GP sequence, right? And now we need to prove A plus B, B plus C, and C plus D are also in GP, right? So how do you do that, right? It's pretty straightforward. We have a sequence here, which is being assumed that it's a GP, right? Now we need to work out based on this assumption, right? This sequence will be GP2. It's pretty straightforward here. So here, let's work out B, so R. So what is R according to this one, right? So this equals to B by A, right? So that means B equals to AR, right? And now we can, now similarly, we have R squared, so that is C equals to AR squared, and then we have D equals to AR3, right? So this is how we find out. So we're gonna do from here. So as it moves forward, right, it will become squared, then it's become to the power 3 to the power 4, right? So now if you're gonna use R squared equals to a C by R, right? So because this is R, then this is R squared, right? So now we're gonna do equals to so B plus C. Now we have a value of R if you compare this equation, right? So that's equals to B plus C times A plus B, right? So this will equals to AR plus AR squared, right, divided by A plus AR, right? This equals to R, right? This pretty much equals to R because you take the A out and and then so you take the AR out, so and in the top, and you take the A out, it will become R, right? So similarly, you can do something for the second one, right? So you can do that for C by D for B, right? So you can do C by D by B plus C, right? So this will become AR squared plus AR3 divided by AR plus AR squared. This will become AR squared times AR, right? 1 plus R, 1 plus R. So this will become R. So that means the common ratio of A plus B, B plus C, and C plus D is R. So you can say that these numbers are a GP, right? So this is how we calculate. So let me explain to you again. So what we've done. So we got a series here, A, B, C, D, right? And this is what we had. And we been told that this is a GP, right? And now we got A plus B, B plus C, C plus D. So we got to prove that these are GP, right? So the best way to prove, so first we work out the value of R. So R equals to, B times A, right? So that means we can also say B equals to A times R, right? Pretty straightforward. Now we calculated the value of C, right? So the way we did, so we R squared, right, equals to C times A. Sorry, C divided by A. So that means C equals to, so A times R squared. So now we went to D, right? So D. So the way to calculate D, so we need to rely on R to the power 3, that equals to D by A, right? So we are taking this as a common, as the first the first term, and then we are working out B, C, and D, right? So that's how we did. So as we move forward, so R will become R squared, then R to the power 3, then R to the power 4, right? Now, we divided these two, right? and then we got a value of r. Then we divided these two, right? These two, right? And then we got the value of r as well. So we got a common ratio between these two, between a plus b, b plus c, and c plus b. So we can say that this is these numbers are in GP, right? So that's how we can work out. Okay, cool. I hope this is clear. My apologies if it's a bit overwhelming. You need to do a little bit of more practice by yourself when you get time, right? So work out different problems by yourself. So yeah. Let me clear this one. Okay, so just cleaning it up. Just won't take much time. Bear with me for a second. Right. Okay, right. Right. All right, so now we're gonna, all right, let me clear this one. So we're gonna move on to our next topic. So what we're gonna do, we're gonna find the sum of n terms of a GP, right? It's similar to what we did for AP, if you remember. So we're gonna do, so it's a bit different compared to AP, right? Because we got to work on two equations here. One, when r is greater than 1, and second, when r is less than 1, right? So let's deal with when r is greater than 1, right? So when r is greater than 1, so the sum of n terms equation will be Sn equals to a r to the power n minus 1, right? Divided by r minus 1, right? So this is this nice and easy equation, right? So this is when r is greater than 1, okay? Now what happens when r is less than 1, right? So the Sn will become a to the power, a times 1 minus r to the power n divided by 1 minus r, right? So this is how you, these are the two equations you need to keep into consideration depending upon the value of r, right? So we're gonna do one exercise here just to give you more clarity here. So let's take the example number 1, right? So find the sum of GP of this one. 1 minus 1 by 2 plus 1 by 4 plus minus 1 by 8 and so on up to 9 terms, right? We have got 9 terms, right? So what we're gonna do, so as usual, so we need to work out the value of a, which is 1, right, from here, right? And then we're gonna work out the value of r equals to minus 1 by 2 over 1, so minus 1 by 2, right, divided by 1, so that's equal to minus 1 by 2. Now value of r, that's less than 1, right? It's because it's obviously it's not greater than 0. It's less than 1, right? So so when it's less than 1, we're gonna use this equation, right? So that's pretty nice and easy, right? Sn equals to a 1 minus rn 1 minus r. So we're gonna find out, so we're gonna find of 9 terms, right? So that means S of 9 equals to a equals 1 minus r is minus 1 by 2, right? Oh, sorry. And value of n equals to 9, right? And equals to 1 minus r minus 1 by 2, right? So you need to work out this one. So that's equals to something like okay, this is equals to 1 minus 1 2 times, well, which is 5 1 2, I presume, 1 minus 1 by 2. So that will become something 1 plus 1 by 5 1 2 divided by 1 plus 1 by 2, right? So this will something becomes 513 divided by 512 divided by 3 by 2. Right, now you can work out, you know, you can use the calculator to work out. So this is how it works, just to give you perception. different. So what we did, right? So we need to work out the 9 term, right? Sum of 9 terms, right? So that's pretty straightforward. We figured out the value of a equals to 1, right? And then r we worked out, by dividing these two, right? And then we realized the value of r equals to minus 1 by 2, which is obviously less than 1, right? So this is less than 1. And now we're gonna use this equation, right? We substitute the value of a, then we substitute the value of a, which is 1. We substitute the value of r, which is minus 1 by 2. We substitute the value of n, which is 9. And then the similar thing we did on the denominator, right? So we worked out the equation. So nice and pretty straightforward. Now we're gonna figure out another example to deal with when r value is greater than 1, right? So it will become more clear. So let me clean this up first, and then we will work out, right? All right. So yeah, I mean, this is how you need to work out based on the value of r, which is very handy though, right? So this is always good to have the equation ready, so that you can figure out, oh yeah, this is based on the value of r. Right, let me clean this. It won't take much longer. So I won't delete the equation just to be there in front of you, so that you don't get confused. Okay, my apologies. I know that it can be a bit overwhelming, but as I said, if you practice more, it will become very clear to you. Right, cool. Okay, so Wiggy, let me let's just stop. Right, okay. All right, so let's do another problem where the value of m, so let's do one simple problem. Okay, so now let's find the sum of, find the sum of GP, right? This one. 2 plus 4 plus 8 plus blah 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 1024. We need to find the sum of 10 terms, right? So let's find the sum of 10 terms, right? So now in this case, it's pretty straightforward. A equals to 2, right? R equals to 4 by 2, so that becomes 2, which is obviously greater than 1. Now, as usual, if the value of r is greater than 1, we're going to use this equation, right? So let's write it down. Sn, that is S of 10, right? That equals to A, which is 2, right, times, and r to the power n minus 1. So what is the value of r? 2. And what's the value of n? That is 10, right? Minus 1, right? Times 2 minus 1, right? So which can be written as 2 times 1024, right, minus 1, and divided by 1. So this will become 2 times 1023, which is 2, 3 to 6, we're gonna go 4, 0, 2, right? So this is nice and easy exercise, right? So this is how you can work out when the value of r is greater than 1 and when the value of r is less than 1. So I hope this is a bit clearer for you. So so what I want you to do, if you are interested more, please go and practice more. Look for exercise out there and see how you can relate these two in your day-to-day life, right? If you can actually relate, or if you can't, right? This is one of the exercises I would actually like you to do. Go and figure out, like I gave you an example in AP, right? How the AP can be used, right, in day-to-day life, right? Where I gave you an example, right? A person, changes job every 5 years, and he will start working at 20, wants to retire at 60, so find out the number of times he changed the job. Something like that, right? So try to see if you can use GP in your real life. Google it, research it, right? If you are interested, right, you'll be surprised, to see the usage of GP in our regular life, right? In a common life scenario. So yeah, I mean, work out the example. I've given you tools now. I've given you equation to which is very powerful. Now you have a power in your hand to do amazing stuff, right? You have an equation, you know how to use, calculate some of n terms in terms of GP, so use the equation, right? and then we can also calculate the terms, right? Which we worked out before. So yeah, this pretty much I wanted to cover today. So yeah, I hope you guys find some value out of today's session. So that being said, adios and greetings from New Zealand. Bye bye. Take care.